So in the last class we were discussing on the simple harmonic oscillator, the quantum mechanical treatment of the simple harmonic oscillator. And in those classes, in the two previous classes, we learned the classical treatment of the simple harmonic oscillator. Then we started to learn the quantum mechanical treatment of the simple harmonic oscillator. So let me remind you about what we just learned in the previous class, and we were considering a system of a system consisting of a particle which is free to vibrate in the plus x and the minus x direction. You suppose that this is x is equal to 0, that is a mean position, and then it can go in the plus x direction to some extent, and then it will come back to the normal position or the equilibrium position. Then it will go to the minus x direction to the same extent. Okay, and this type of motion is periodic, and so we can consider this as a simple harmonic oscillator. And we constructed the Schrodinger wave equation for this simple harmonic oscillator, and the Schrodinger wave equation is minus h square divided by 8 pi square m d square by dx square plus 2 pi square m nu square x square into psi is equal to Si. In this was the kinetic energy part of the Hamiltonian, and this is a potential energy part of the Hamiltonian. Okay, and then we modified the Schrodinger wave equation with the assumption of alpha is equal to 8 pi square me by h square and beta is equal to 4 pi square m nu by h. Then we got a modified Schrodinger wave equation, that is d square psi by dx square plus alpha minus beta square x square into psi is equal to 0. Okay. Then we again assumed that root beta into x is equal to y. And then we again modified this equation, and we got and the next to modified Schrodinger wave equation, that is d square psi by dy square plus alpha by beta minus y square into psi is equal to 0. And this equation have a general solution, psi is equal to f of y exponential minus y square by 2. And this is what we learned in the previous class. Okay, and at that time I said that I do not know what is the form of this function f of y. Okay, and in this class we are going to see what is the form of f of y. Okay, that is what we are going to do in this class. So with this basic, let us continue our study on the quantum mechanical treatment of the simple harmonic oscillator. And today our task is to find out what is f of y. What is f of y? Okay. So that is what we are going to do. Okay. And now what I am going to do is I am going to differentiate, okay, this equation for psi, that is equation number 5. Differentiate this equation with respect to y. So differentiate equation number 7 with respect to y. Means I am going to see d psi by dy. Okay, so d psi divided by dy, sorry, not dx, dy, d psi by dy is equal to, what is d psi by dy? First function f of y. Let me just write f instead of f of y. Okay, if I write f, that just means that is f of y. Okay, so it will be simpler to write f instead of f of y. So first function f into differential of the second is exponential minus y square divided by 2 into differential of the term inside the bracket. Okay, that is minus 2y divided by 2, minus 2y divided by 2. Okay, okay, then 2 and 2 will be cancelled. Okay, then it is minus y only, plus second function is exponential minus y square divided by 2 into derivative of the first. Derivative of the first is df divided by dy. Okay, so that is d psi by dy. So I can just write it like f into minus 2y divided by 2, that is equal to minus y. So let me write f into minus y exponential minus y square divided by 2, okay, into plus exponential minus y square by 2 into df by dy. So exponential minus y square by 2 is in both terms. So I will take it as a common factor later on. Okay. So plus, let me write exponential minus y square divided by 2 df divided by dy. So let me take exponential minus y square by 2 as a common factor. Then I can write f of f into minus y into f into minus y plus df by dy, df divided by dy into common factor. Common factor is exponential minus y square divided by 2. Okay. So now I have d psi by dy. Now I am going to find out d square psi by dy square. D square psi by dy square. D square psi divided by dy square is equal to, what is d square psi by dy square? We already have d psi by dy, so I can take the next derivative of this one. Okay, that is d by dy of this term, that is d square psi by dy square. So what is d by dy of this term? Again, we have to take it as the as the product of two functions. We can take the function inside the terms inside the square bracket as the first function, and exponential minus y square by 2 as the second function. Okay, so let me write first function, that is f into minus y and plus df divided by dy, that is first function, into derivative of the second, that is exponential minus y square by 2 minus y square by 2 into minus 2y by 2, that is equal to minus y. So I can write minus y, okay, plus second function, that is exponential minus y square by 2, exponential minus y square divided by 2 into derivative of the first. So derivative of the first is that the first term already is a sum of two functions, right? So we have to take the derivative of this one. So that is f, that is the derivative of the first function, that is f into the derivative of minus y, that is equal to minus 1, f into minus 1, because this is already at f is already a function of y. So this function into another function, right? So we have to take a first function f into derivative of this one, okay, that is minus 1, plus second function, that is minus y, into derivative of the first, that is df by dy, df divided by dy. Okay, so now we have the derivative of this one plus the derivative of this one, the second one, that is d square f by dy square. Okay, now we have everything. So that is equal to f into minus y df by dy. Here we have exponential minus y square by 2, okay, in this term, and here also we have exponential minus y square by 2. So we can take it as a common factor. So let me take exponential minus y square by 2 as a common factor into okay, f into minus y minus df by dy, right? So I can write it like plus f into f of minus y. Here also I have f into minus 1 plus y into df by dy. Okay, let me okay. So f into minus y into minus y here. Okay, I will put it together. Then I can write it like f into minus y into minus y. Okay, that is equal to fy square fy square plus df by dy into minus y. Okay, then I can write like a minus y df by dy. Okay, so these two terms are there, and now these terms, okay, that is minus f then minus y df by dy again, minus y df by dy, okay, then plus d square f by dy square, okay, d square f by dy square. Be very careful while writing all these steps, okay, don't miss any plus or minus sign or anything, because this is going to be a long derivation. Okay, so that is equal to d square f by dy square. I will write the exponential minus y square by 2 at the end. Okay, let me write from what is inside this bracket. So let me write the second derivative of the f first. D square f by dy square. So this one. Then I will go for the first derivative of f. That is, there are two terms with the first derivative of f. That is minus y df by dy and again minus y df by dy. So I can write it like minus 2y df by dy. Okay. Then I will go for f terms. Okay. That is, f terms are fy square minus f. So f is a common factor in both of these terms. Then I can write like plus y square minus 1 into f. Okay, y square minus 1 into f. Okay. Okay, now I have written everything inside the bracket into exponential minus y square divided by 2. Okay. Now I have this equation, and in this equation we have d square psi by dy square. So let me give a number to this one, because why I found out this d square psi by dy square, because I am going to substitute this d square psi by dy square in this equation. Okay, so that is why I have done all these steps here. Okay, and let me give this as equation number 6. Okay, equation number 6. Okay, and now what I am going to do is I am going to substitute this d square psi by dy square and also psi, okay, expression for d square psi by dy square and also expression for psi in this equation. This equation what we already have from the previous class. Okay, this equation d square psi by dy square plus alpha by beta minus y square into psi equals 0. So I will substitute for psi and also for d square psi by dy square. So that is equation number 4. Okay, so equation number 4. Psi already is there here. That is psi. So I will take the expression for psi from equation number 5 and d square psi by dy square from equation number 6. So let me say substitute 5 and 6 in equation number 4. Okay, so what I will get when I am substituting these two terms in equation number 4? I will get d square psi by dy square. That is the first term in equation number 4. D square psi by dy square. This one. Okay. I will give the expression for that one first. That is d square f by dy square. D square f by dy square. You can get it from here. Minus 2y into df by dy. Df by dy plus y square minus 1 into f. Okay, that is multiplied with exponential minus y square divided by 2. So now we have the first term in equation number 4. Okay, that is d square psi by dy square, first term in equation number 4, this one. plus alpha by beta minus y square into psi. Okay, so alpha plus alpha by beta minus 1 in minus y square, alpha by beta minus y square into psi. What is psi? Psi is equal to f of y exponential minus y square by 2. That also I will substitute there. So f of y, instead of f of y I will write simply f. Okay, f into exponential minus y square divided by 2. Okay, that is equal to 0. That is the right hand side of equation. That is d square. I can take exponential minus y square by 2 as a common factor from both. So I can write like d square f by dy square minus 2y df by dy, okay, plus y square minus 1 into f, and here also I have alpha minus y square into f. Okay, both of them have f as the common factor. So let me put f outside the bracket, and then I will write all these terms together. Okay, y square minus 1 plus alpha by beta minus y square. So y square will be cancelled from both. Okay, y square minus y square. So what is remaining is alpha by beta minus 1. So let me write like alpha by beta minus 1. So these two terms have f as the common factor, right? Okay. So now this is multiplied by, all this is multiplied by exponential minus y square by 2. That is a common factor in these two terms. And that is equal to 0. Okay. And now we have an equation, and the left hand side of the equation is some expression, but the right hand side is 0. If the left hand side has to be equal to 0 as it is in the right hand side, then there are two possibilities. Either this one means exponential minus y square by 2 should be equal to 0. This term should be 0. Otherwise this term should be 0. Either of these terms should be 0, then only this equation will be valid, right? So let us consider what will happen if exponential minus y square by 2 is 0. If exponential, let me take another ink, otherwise it will be difficult to see. If exponential minus y square by 2 is equal to 0, what will happen if exponential minus y square by 2 is equal to 0? If exponential minus y square by 2 is equal to 0, now you can look for the expression for psi. What is the expression for psi? That is given in equation number 5. Then psi is equal to f of y into 0, because exponential minus y square by 2 is equal to 0. Then psi will be equal to 0. So if this is correct, then psi will be always 0. Okay. So if f of exponential minus y square by 2 is 0, it indicates that no matter what is the value of y, independent of the value of y, okay, or for all values of y, psi will be 0. It means wave function is completely 0. That is meaningless, right? There should be some valid wave function for any value of y. If for all values of y, if psi is 0, it means that nothing is there. No particle is existing. That is a meaning. That is not true. Therefore, we cannot say that exponential minus y square by 2. So this is not possible. Psi cannot be 0 for all values of y. For all values of y. This is not possible. Okay. Therefore, we can exclude this possibility. Then what is the only possibility? The only possibility is that the term inside this big bracket, okay, that should be equal to 0. Means that d square f by dy square minus 2y into df by dy plus alpha by beta minus 1 into f that should be equal to 0. That is the only possibility. Okay, so let me call this as equation number 7. This is equation number 7. Okay, and this equation d square f by dy square minus 2y into df by dy plus alpha by beta minus 1 into f is called Hermite's differential equation. This is called Hermite's differential equation. Hermite's differential equation. Okay, so now we have a new equation called a Hermite's differential equation. This is very important. Hermite's differential equation. This is Hermite's differential equation. Okay, so now the solution of this Hermite's differential equation, it can be obtained by a polynomial method. Okay, so what we are going to do is that in order to obtain the solution of this Hermite's equation by polynomial method, we are going to express f, okay, f as a power series, that is f is equal to a0 y raised to 0 plus a1 y raised to 1 plus, okay, this is plus, okay, plus a2 y square plus a3 y cube plus a4 y raised to 4 plus etc. Okay, so we are expressing f, or we are expanding f as a power series, okay, or power series of y. Okay, y raised to 0, y raised to 1, y raised to 2, y raised to 3, y raised to 4, etc. And each term has some coefficient, that is a0, a1, a2, a3, a4, etc. respectively. Okay, so we are expressing f as a power series. So now let me find out df by dy. Okay, df by dy, because you know that we have this term df by dy in our Hermite's differential equation. Then we have d square f by dy square also. I am going to find out what is df by dy and d square by dy square if we are expressing f as a power series like this. Okay, therefore df by dy is equal to a0 into y raised to 0. What is y raised to 0? That is 1. And therefore we can simply write it as a0. a0 is a constant. Therefore df by dy for this term is 0. So we can just neglect this one. And next one is y raised to 1. So what is the differential of y raised to 1? d by dy of y, that is equal to 1. So we have a1 into 1, that is equal to a1. Like that we can do the differentiation in all these terms. Then we have 2a2y, because differential of y square is equal to 2y. That's why I have written like 2a2y plus 3a3y, sorry, I am getting some notifications here. Let me close it, otherwise it will be captured. Okay, 3a3y, let me close this. Then sorry. So 3a3y, then 3a3y square plus 4a4y cube, right? 4a4y cube plus etc. Okay, that is df by dy. And now we can find out d square f by dy square, d square f by dy square. That is equal to 1 into 2 into a2. Okay, because this term will be 0, and here I have 2a2 into 1. That 1 I am writing here, 1 into 2 into a2 plus 3a3y square. The differential of this one 3a3 into y, right? 3a3 into 2y, okay? 2y. So let me write y here, but the 2 is here. 2 into 3 into a3y plus 4 a4 into 3y square. Let me write 3 here and y square here. 3 into 4 into a4 y square plus etc. Okay, plus etc. So I have this series of equations here, and let me call this series of equations, okay, all these equations together as equation number 8. Okay, now I have expression for f df by dy into d square f by dy square. So what I am going to do, you can now guess what I am going to do. I am going to substitute these equations in equation number 7. So substituting 8 in 7, substituting 8 in 7, substitute 8 in 7. Okay, then I get first term in 7 is d square f by dy square. So let me write that first. 1 into 2 a2 plus 2 into 3 a3y plus 3 into 4 into a4y square plus etc. That is the first term in equation number 7. Okay, plus what is the next term in equation number 7? That is minus 2y into df by dy. Okay, so let me write I have to multiply with the 2y with every term in df by dy. Okay, then I will get a1 into minus 2 into y. Okay, so let me write it like plus, or I can take minus as minus outside. Okay, so minus 2 into y into all the terms in this df by dy. Okay, so I can write it like minus 2 into a1 into y, right? Because I am multiplying with the 2y. So let me write it in a better way, because the writing in this way will be helpful later on. So let me write like, instead of 2, I will write 2 into 1 into a1y. Okay, a1y. What I have done is that I have just multiplied a1 with 2y. That's all. Okay, 2y comes from equation number 7's second term. This 2y. Okay, so 2y into a1, that is 2 into 1 into a1y. Okay, 2 into 1 into a1y. Now next term, okay, that is 2 into a2 y into y, that is 2 into a2, 2 into 2 into a2 y square. Okay, so plus 2 into a2 y square. This 2 came from the equation number 7, and the additional y here also came from equation number 7. Okay, plus 2 into 3 into a3y cube plus etc. Now that is the second term, plus the last term is alpha by beta minus 1 into f. Okay, alpha by beta minus 1 into f. So let me write it like plus alpha by beta minus 1, alpha by beta minus 1 into, what is the first term in f? That is a0 y raised to 0, means a0. So let me write it like a0 alpha by beta minus 1 into a0. Okay, plus next one alpha by beta minus 1 into a1y plus alpha by beta minus 1 into a2y square plus etc. That is the third term. And now every term, all the terms in the left hand side of equation 7 are there, and the right hand side is simply 0, that is equal to 0. Okay. And now you look at this equation, and this equation will be satisfied only if, or this equation will be true only if the coefficients of all powers of y is equal to 0. Okay, because we have different powers of y here. This is a term with y raised to 0. This is a term with y. We can see similar terms of y here also. Okay, and another term of y here also. So y will have a coefficient altogether from all this. And then we can see the y square term here, y square term here, and y square term here. So you can take y square as the common factor from all these three terms and put everything inside a bracket as the coefficient, right? And therefore this is also a series of different powers of y. Okay, and the right hand side is equal to 0. So this equation will be valid only if the coefficients of each power of y is equal to 0. Then only this equation will be true. So what we can write is coefficient of y raised to 0 must be 0. Coefficient of y raised to 1 must be equal to 0. Coefficient of y square must be equal to 0. So we can write like that. So let us pick the coefficients of different y terms, okay, or different powers of y. So for y raised to 0, okay, what is the coefficient of y raised to 0 of this one? The coefficient of y raised to 0 is 1 into 2 into a2 plus any other y raised to 0 term here also, right? Alpha by beta minus 1 into a0. This is also y raised to 0 term. Y raised to 0 means 1. Okay. So the coefficient is 1 into 2 into a2. 1 into 2 into a2 plus alpha by beta minus 1 into a0 is equal to 0. This is a coefficient of y raised to 0. Okay, that is equal to 0. And for y raised to 1, what is the coefficient of y raised to 1? So this is a y term, this is a y term, and this is also a y term. So what is the coefficient? We can write like 2 into 3 into a3, right? 2 into 3 into a3 plus next to y term is 2 into 1 into a1, but that is a minus term. Okay, here we have alpha by beta minus 1 into a1, that is also a y term. So I will write the positive term first, that is alpha by beta minus 1, alpha by beta minus 1, alpha by beta minus 1. Then what is here? Into minus 2 into 1, minus 2 into 1. Okay, then into a1, because this term also has a1, this term also has a1, so a1 will be a common factor of these 3. So into a1, that is equal to 0. Okay, and for y square, we can write like, what is y square's coefficient? 3 into 4 into a4, 3 into 4 into a4 plus, then next term here is alpha by beta minus 1, right? Alpha by beta minus 1, then minus, here the then is 2 into 2 into a2. Okay, so we can write like minus 2 into 2, 2 into 2, and all these three terms have a2 as a common factor, that is a2, so that is equal to 0. And similarly for y cube, for y cube, we can write 4 into 5. Now you can guess what is next. 4 into 5 into a5. Okay, that is the coefficient of y cube here. Okay, I have not written here, but you can imagine what is that. Okay, y cube, and then plus alpha by beta. From this series, you can now imagine what is next. Alpha by beta minus 1 minus 2 into, here it is 1, here it is 2. So what is coming next? 3, right? 2 into 3 into a3, because a1, a2, a3, that is equal to 0. Okay, that is for y cube. So 4 into 5 into a5 plus alpha by beta minus 1 minus 2 into 3 into a3 is equal to 0. Like that, now you can go on like this, and then you can imagine what is for y raised to k. Okay, what is for y raised to k? For y raised to k, we can write like for y raised to 3 it is 4, and y raised to k it should be k plus 1. First one should be k plus 1, k plus 1 into 4 into 5, right? So we have to write k plus 1 into k plus 2. Okay, so this term, the first first two things are there, first two numbers are there, like 4 into 5 we have here k plus 1 into k plus 2 into, when it is y cube, here we have a5, when it is y2 we have a4, when it is y1 we have a3, like that. When it is y raised to k, we have a k plus 2, right? So we have to write a k plus 2 plus, next one is alpha by beta minus 1, no changes there, and minus 2. 2 is everywhere there, right? So we can write again 2 into what is there in the what is multiplied with the 2. Here when it is y raised to 1, 2 is multiplied with 1. When it is y raised to 2, 2 is multiplied with 2. For y cube it is 3, and like that for y raised to k it should be k. So we can write like a minus 2k into, here for y1 it is a1, y2 a2, y3 a3, like that. For y raised to k we can write ak. So ak is equal to 0. Okay, so now we have a general equation here for y raised to k, and from this one we can write a k plus 2 is equal to, what is a k plus 2 from this equation? A k plus 2 is equal to alpha by beta minus 1 minus 2k into ak. This term is going to the right hand side, then it will be minus of alpha by beta minus 1 minus 2k into a raised to k, no, not ak, not a raised to k, it is ak. Okay, ak is the coefficient of the y raised to k. Okay, so divided by what is that? K plus 1 into k plus 2, k plus 1 into k plus 2. Okay, so now we have an expression for a k plus 2, expression for a k plus 2, that is a, what is a k plus 2? A k plus 2 is the coefficient of, this one is the coefficient of y raised to k plus 2, right? Y raised to k plus 2 in our power series. And what is ak? Ak is the coefficient of y raised to k in our power series. Okay, so we have the coefficient of y raised to k in terms of the coefficient of y raised to k plus 2 in terms of the coefficient of y raised to k. Okay, so this formula, okay, this formula is called a recursion formula. What is that? A recursion formula. This is called a recursion formula. Okay, so this recursion formula permits the calculation of ak plus 2, which is the coefficient of y raised to k plus 2, in terms of ak, which is the coefficient of y raised to k in the power series. Okay, that is the importance of this recursion formula. Means that if you know ak, then you can find out ak plus 2, right? So that is very important. So suppose we set a1, suppose we set a1 set a1 is equal to 0. Okay, so this is arbitrarily we are setting, arbitrarily is equal to 0. Then if a1 is equal to 0, then what is the consequence of this recursion formula if a1 is equal to 0? If you know a1, then we can know a1 plus 2 means a3, right? So if you know a3, then we can find out a3 plus 2 means a5. Like that, if a1 is equal to 0, then a3 will be 0, because when we substitute 0 for ak here, a1 is equal to 0, then a3 will be equal to 0, right? So a1 is equal to 0, it means that then a3 is equal to 0. a3 is equal to 0. If a3 is equal to 0, a5 is equal to 0, right? a5 is equal to 0. And if a5 is equal to 0, a7 is equal to 0, etc. Right? So if that is the case, then our power series f, the power series f is equal to a0 plus, because all the odd terms will be 0, then we can write like a0 plus a2 y square, because a1 term will be cancelled, so the remaining one is a2 y square. A3 term will be cancelled, so then the next one remaining is a4 y raised to 4 plus a6 y raised to 6 plus etc. Okay, so here we have we have an even set 0, 2, 4, 6, etc. So this is an even set. Okay, even set. And similarly, if we set a0 is equal to 0, set a0 is equal to 0. If a0 is equal to 0, then we can write what will be 0? a0 is 0, then a2 will be 0, then a2 is equal to a4 is equal to a6 equal to etc. equal to 0. If that is the case, then f is equal to a0 is 0, a1 term will exist, then we can write a1y plus a3 y cube plus a5 y raised to 5 plus etc. etc. Okay, this is the power series. Okay, now this is an odd set, right? Odd set. Okay, so in either case, even if this is the case, even if one of the term is equal to 0 in these ones, then also we can see that even if the series is reducing like even set or odd set, and we can say that in neither of these sets, okay, the term will never in any of these sets, means in the even set or in the odd set, in any of these terms, the terms are never going to end. Okay, it is going to infinity, right? So we can get an infinite number of terms. If we, even if we are going like even terms here, we can go to infinity. Even if we are going like odd terms here, then also we can go to infinity. So even if some of the terms are getting reduced in this way, then also we cannot neglect the possibility of infinity, right? Or infinite number of terms. But if there are infinite number of terms, what is the problem? As if infinity is there, then we can see that y raised to k tends to infinity. K can be 1, k can be 0, 2, 4, 6, etc. in the series, and k can be 1, 3, 5, etc. in the series. Even if that is not the case, we can write we can consider, even if we are taking the original power series, then also we can consider like k is equal to 1, 2, 3, etc. like that. There is no end, right? So as k tends to infinity, or k tends to infinity, then y raised to k tends to infinity, right? Y raised to k tends to infinity. If y raised to k tends to infinity, then f will also tend to infinity. So f of y tends to infinity. So that's a problem. Here we have a problem that our function f of y tends to infinity. That is not quantum mechanically allowed. If that is the case, then our solution will be an infinite solution. That is not possible. Okay, our solution should be, or wave function must be finite, because f of y is a part of psi, right? We know that here. See, psi is equal to f of y into exponential minus y square by 2. So f of y is a part of psi. So if f of y tends to infinity, psi also will tend to infinity. That is not allowed. Okay, psi must be finite. So there is a problem with this power series, because it is going to be infinite. Okay, so now there must be some condition. Which restrict the number of terms in the power series. Okay, f എന്ന് പറയുന്ന സീരീസിൽ ടേംസിനെ ലിമിറ്റ് ചെയ്തില്ല എന്നുണ്ടെങ്കിൽ അതൊരു ഇൻഫൈനൈറ്റ് ആയിട്ടുള്ള ഒരു ക്വാണ്ടിറ്റി ആയിട്ട് മാറും. അത് ക്വാണ്ടം മെക്കാനിക്കലി അലൗഡ് അല്ല, അല്ലെങ്കിൽ ക്വാണ്ടം മെക്കാനിക്കലി അക്സെപ്റ്റബിൾ അല്ല. കൂടുതൽ കറക്റ്റ് ആയിട്ട് പറഞ്ഞാൽ ക്വാണ്ടം മെക്കാനിക്കലി അക്സെപ്റ്റബിൾ അല്ല. അതുകൊണ്ട് ഈ എഫ് എന്ന് പറയുന്നത് ഒരു അക്സെപ്റ്റബിൾ വേവ് ഫംഗ്ഷൻ ആവണമെന്നുണ്ടെങ്കിൽ, അല്ലെങ്കിൽ ഒരു അക്സെപ്റ്റബിൾ ഫംഗ്ഷൻ ആവണമെന്നുണ്ടെങ്കിൽ, then there must be some condition to limit the number of terms in it, right? There must be some condition to limit the number of terms, or there must be some condition like when k attains some value. Okay, when k attains some value, then the series will close. Okay, it means that if it is to be finite, if this f of y must be finite, then we have an equation here, that is a recursion formula. At some value of k, then this next coefficient should be equal to 0. അല്ലേ? k യുടെ ഒരു പർട്ടിക്കുലർ വാല്യൂ ആകുമ്പോൾ എന്ത് ചെയ്യണം? അതായത് എ കെക്ക് ഒരു പർട്ടിക്കുലർ വാല്യൂ കിട്ടുമ്പോൾ എന്ത് ചെയ്യണം? അടുത്ത കോഎഫിഷ്യന്റ് എന്ന് പറയുന്നത് 0 ആയി പോകണം. ആ ഒരു കണ്ടീഷൻ ഉണ്ടെന്നുണ്ടെങ്കിൽ ആ എ കെ ആയിരിക്കും അവിടുത്തെ കെ ആയിരിക്കും അവിടുത്തെ ലാസ്റ്റ് ടേം എന്ന് പറയുന്നത്. അതിനുശേഷമുള്ള ടേമുകൾ എന്ത് ചെയ്യും? 0 ആയി പോകും. അതായത് എ കെ പ്ലസ് 2 മസ്റ്റ് ബി 0 for some value of k, right? Then we can limit the series, right? So what is the condition then? If for some value of k, for example n, for some value of k, for example k is equal to n, k യുടെ വാല്യൂ n ആകുമ്പോൾ എന്ത് ചെയ്യും? നമ്മളുടെ പവർ സീരീസ് എൻഡ് ചെയ്യണം. അതായത് നെക്സ്റ്റ് കോഎഫിഷ്യന്റ് എന്ന് പറയുന്നത് ഇതായി പോകണം, 0 ആയി പോകണം. അങ്ങനെ നെക്സ്റ്റ് കോഎഫിഷ്യന്റ് 0 ആയി പോകണമെന്നുണ്ടെങ്കിൽ എന്താ സംഭവിക്കേണ്ടത്? നമ്മുടെ റിക്കർഷൻ ഫോർമുലയാണ് നെക്സ്റ്റ് കോഎഫിഷ്യന്റിനെ തരുന്നത്, അല്ലേ? അപ്പോൾ റിക്കർഷൻ ഫോർമുല അനുസരിച്ച് ഉള്ള നെക്സ്റ്റ് കോഎഫിഷ്യന്റ് 0 ആകണമെന്നുണ്ടെങ്കിൽ ഈ റൈറ്റ് ഹാൻഡ് സൈഡ് എന്താകണം? 0 ആയി പോകണം. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇവിടുത്തെ ന്യൂമറേറ്റർ, ഇതിനകത്ത് ന്യൂമറേറ്റർ 0 ആയി പോയാൽ മതി, അല്ലേ? അതായത് ആൽഫ ബൈ ബീറ്റ -1 -2k എന്ന് പറയുന്നത് എന്താകണം? 0 ആയി പോകണം. എപ്പോഴാ? when k attains some value n. So let me write the numerator here. അങ്ങനെ ന്യൂമറേറ്റർ 0 ആവണമെന്നുണ്ടെങ്കിൽ എന്തുവായി പോകും? a k plus 2 0 ആയി പോകും. അതായത് a n plus 2 എന്ന് പറയുന്നത് 0 ആയി പോയിക്കോളും. ഓക്കെ, so let me write the numerator here of the recursion formula, that is alpha by beta -1 -2k, that is numerator of the recursion formula. That must be equal to 0 for some value of k which is equal to n, that is alpha by beta -1 -2n, that is equal to 0. ഇങ്ങനെ ഒരു കണ്ടീഷൻ ഇത് ഹോൾഡ് ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ then the power series will be a finite power series. Okay, it will be a finite one. So from this one, alpha by beta -2n is equal to 0. Therefore, we can write like alpha by beta. Alpha by beta is equal to 2n plus 1. So that is the condition. So the condition is that in our equation alpha by beta must be equal to 2n plus 1, where n is equal to n എന്ന് പറയുന്നത് കെയുടെ ഏത് വാല്യൂം ആകാം n എന്ന് പറയുന്നത്. കെയുടെ വാല്യൂസ് ഏതൊക്കെയാണ് പോസിബിൾ ആയിട്ടുള്ളത്? 0 ഉണ്ട്, 1 ഉണ്ട്, 2 ഉണ്ട്, 3 ഉണ്ട്, അതുണ്ട് അല്ലേ. അപ്പോൾ കെയുടെ ഏതോ ഒരു വാല്യൂവിനാണ്, ഏതോ ഒരു വാല്യൂ n ആകുമ്പോഴാണ് ഈ ഒരു കണ്ടീഷൻ അക്സെപ്റ്റഡ് ആകുന്നത്. അതുകൊണ്ട് കെയുടെ ഏത് വാല്യൂവും n-ന്റെ വാല്യൂ ആകാം. Therefore n is equal to 0, 1, 2, 3, etc. Okay. So alpha by beta is equal to 2n plus 1. That is a condition where n is equal to 1, 2, 3, etc. അപ്പോൾ ഈ ഒരു കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ നമ്മളുടെ സൊല്യൂഷൻ എന്ന് പറയുന്നത് എന്തായിരിക്കും? ഒരു ഫൈനൈറ്റ് സൊല്യൂഷൻ ആയിരിക്കും. So when this condition is held or when this condition is obeyed, or means alpha by beta is equal to 2n minus 1, then the resulting series will be the resulting series will have a finite number of terms in it. അല്ലേ? അപ്പോൾ അങ്ങനെയുള്ള സീരീസിനകത്ത് ഫൈനൈറ്റ് നമ്പർ ഓഫ് ടേംസ് ആയിരിക്കും ഉള്ളത്. ഓക്കെ, അങ്ങനെയുള്ള ആ റിസൾട്ടിംഗ് പോളിനോമിയൽ എന്ന് പറയുന്നത് അതിനെയാണ് നമ്മൾ the resulting series will have a finite number of series, or that is a polynomial, and that polynomial is called the Hermite polynomial. Hermite polynomial. Okay, so what is Hermite polynomial? When 2n plus 1 is equal to alpha by beta, then the resulting series will be a finite series. Okay, and that is called the Hermite polynomial. Hermite polynomial. So Hermite polynomial. ഓക്കെ, അപ്പോൾ നമ്മൾ എഫ് ഓഫ് വൈ എന്ന് പറയുന്നതായിരുന്നു നമ്മളുടെ ഇവിടുത്തെ പോളിനോമിയൽ എന്ന് പറയുന്നത്. സോ വി എക്സ്പ്രസ്ഡ് എഫ് ഓഫ് വൈ ആസ് എ പവർ സീരീസ്, ആൻഡ് എഫ് ഓഫ് വൈ ഈസ് ആക്ച്വലി ആൻ ഇൻഫിനിറ്റ് സീരീസ്. ഒരു ഇൻഫിനിറ്റ് സീരീസ് ആയിട്ടാണ് നമ്മൾ കണ്ടത്. ബട്ട് എഫ് ഓഫ് വൈ ബിക്കം ഫൈനൈറ്റ്. ഇറ്റ് ബിക്കം ഫൈനൈറ്റ്, ആൻഡ് once it becomes finite, we can call this as a Hermite polynomial. Okay, Hermite polynomial. Okay, so the expression for Hermite polynomial is that, so we can call this as hy. Okay, since now f of y becomes hy because f of y is now a finite series and it is called a Hermite polynomial. So let me write it as h of y, and h of y actually depends upon the value of n. So let me write it as hny. Okay, hny. So hny or Hermite polynomial is equal to minus 1 raised to n exponential y square d raised to n by dy raised to n exponential minus y square. Okay, this is the expression for Hermite polynomial. Or Hermite polynomial is defined as h and y is equal to minus 1 raised to n exponential y square d raised to n by dy raised to n exponential minus y square. Okay, so now we have a solution. So instead of f of y, we can write h and y in our solution. So what is the expression for psi? Psi is f of y exponential minus y square by 2. We already have this expression here. That is psi, this one. Okay, psi is equal to f of y exponential minus y square by 2. So instead of f of y, we can write h and y. Okay, so our solution now is psi is equal to h n y, that is a Hermite polynomial, multiplied by exponential minus y square by 2. Okay, now we have the solution for psi, and still this solution is not normalized, and here we have a h and y, that is a new term, that is Hermite polynomial, and we can find out the values of Hermite polynomial for different values of n. Okay, and you have to note here that we have written like alpha by beta is equal to 2n plus 1, or we can write like alpha by beta minus 1 is equal to 2n from this equation, right? Alpha by beta minus 1 is equal to 2n. You can write like that. Alpha by beta minus 1 is equal to 2n. Have you found this alpha by beta minus 1 anywhere else? Yes, you can go to our equation, this one. Equation number 7. In equation number 7, we have alpha by beta minus 1. So instead of alpha by beta minus 1, we can give 2n here, right? Because alpha by beta minus 1 is equal to 2n. So if we are giving 2n here in this equation, that is d square f by dy square minus 2y into df by dy, 2n f is equal to 2n f is equal to 0. Okay, and the f and the n will have the value 0, 1, 2, 3, etc. So you will get a different Hermite differential equations from here. Okay, so what are the possible Hermite differential equations? So the Hermite differential equations are actually restricted with the value of n. So the different Hermite differential equations possible are d square f by dy square minus 2y into df by dy, okay, plus alpha by beta minus 1, that we can write like plus 2n into f, that is equal to 0, where n is equal to 0, 1, 2, 3, etc. Okay, so we can have different equations like for n is equal to 0, d square f by dy square plus minus 2y into df by dy, the n is equal to 0, so this term will be 0. So that is equal to 0. That is one equation. Okay, and the next possible is d square f by dy square minus 2y into df by dy minus plus 2nf. Now the next possible value n is equal to 1. So 2n is equal to 2. So 2 into f, that is equal to 0. For n is equal to 2, the equation becomes d square f by dy square minus 2y into df by dy plus 2n. 2n in this case is 4. 4f is equal to 0. So we have only certain restricted Hermite differential equations. Okay, 2f, 4f, like that. Okay, so from this one, we have a quantum number, right? We have a quantum number, and this quantum number actually limits the solutions. Okay, so when these terms are limited, like 0, 2f, 4f, and 6f, etc., then the solutions will also be limited. So we can have only certain possible values of psi, certain restricted values of psi. Okay, means the system can sit only in certain restricted states. That is the indication of that. Okay, and so those things we will learn in the next video. Now I am going to wind up this video, and what we are going to do next is that we will find out the value of this psi for different values of n. Okay, this is the expression for psi, and then we will find out the value of psi for different values of n. And before that, we have to normalize this equation. Okay, one normalization factor should be there. So the normalization factor should be included here as n, and we have to find out the expression for n also, and then we will find the expression for h and y for different values of n, and then we will work out with this one, and we will find out the different possible wave functions like psi 0 or psi 1, etc., for different values of n. Okay, that is what we are going to do next. Those things we will do in the next class. And in this class, we have come to a solution for the wave function for the simple harmonic oscillator psi. Okay, this solution is not yet complete, and we have to get the normalization factor. So then we will convert the y in terms of x also. Okay, because we already know that y is equal to root beta into x. those things we will do in the next class. So if you have any doubt, you can ask me and I will be happy to help you. Okay. And I know this is a lengthier solution, but I suggest you to go through this derivation many times so that you will not forget it if it is asked in the examination. Okay. And thank you for watching and stay tuned.